right? So, I mean, you can go through the process. If I'm looking for U dot V cross W, then you can actually find the cross product of V and W, get that result, and then dot it with whatever the U is. But a nifty little shortcut for that would be to actually determine the determinant of the 3 by 3 matrix that makes up your something. I lost it there for a second. The vectors that make up your 3 by 3 matrix. So I'm just going to pop it in. And again, you've already been assessed on determinants. You kind of want to be able to just use them at this point. You know, cross product is a little different because it's not really calculator friendly, but this is purely numeric, so we're, I think, in pretty good shape. Let me just show you something else. Matrix. Two, -3. Okay, so determinant of matrix A snip this. Where'd my snipping tool go? Have I not used it yet today? That's so weird. Pretty rare. Oh, this looking good. All right. And that is going to kind of get us started in understanding why we're allowed to do things like when we're doing the dot product, treat a vector as a row vector in some cases and a column vector in other cases. Right? Now, the volume of a parallelepiped the absolute value of the triple scalar product, or the determinant of your 3 vectors. Now, the issue here is sometimes you're given way more than 3 vectors that make up your parallelepiped, because you're looking at a parallelogram that's scaled up into 3 dimensions. So it's going to have 6 sides, kind of like a cube, which means that your vertices aren't just limited to whatever would be pointed at by 3 vectors. You could have upwards of, let's see, 4, 8 vertices. Right, in which case you could have a total of 8 vectors. But we're not going to find a determinant of a 3 by 8 matrix. So what we need to do in some cases is scale it down to the minimum number of vectors necessary to come up with the triple scalar product or the determinant. But basically, it boils down to the idea that all you really need is the determinant, and you'll have the volume of the parallel pipette. Geometrically, that's how they're actually defined. All right, so you just type this in, find the determinant. If there's a negative sign, drop it and call it a day. All right, so that's nice and easy. In number 11, it says use the triple scalar product to show that the vectors are coplanar. Coplanar means that they live on the same plane. Right? If they live on the same plane, you're talking about three vectors that when you find the determinant, it gives no volume. All right? So volume equals 0 because there's no height. All right? So if there's no volume, then you're looking for a determinant to be equal to 0. All right? So it's the same scale, just a slightly different context.